Hello and welcome to another GCSE revision video, and in this video we're going to be looking at where we get the quadratic formula from. When a quadratic expression can be factorised into x plus n squared, it is called a perfect square. If we expand out x plus n squared, we get x squared plus 2nx plus n squared. Completing the square then is about turning a quadratic equation into the form x squared plus 2nx plus n squared. So when we have an equation in the form ax squared plus bx plus c equals 0, our first job is to divide everything through by a. This effectively removes the a from the x squared term. So ax squared plus bx plus c equals 0 becomes x squared plus b over ax plus c over a equals 0. Now to get our equation in the form that looks something like x squared plus 2nx plus n squared equals 0, we're going to have to add a numerical term that is equivalent to half of the x term squared, because the x term is 2n, so we want to halve that 2n to make n, and then we need to square it to make n squared. But we must remember that whatever we do to one side of an equation, we must also do to the other side. So our x squared plus b over ax plus c over a equals 0 becomes x squared plus b over ax plus b squared over 2a all squared plus c over a is equal to b squared over 2a squared all squared. So what we've basically done is taken the x squared term, which is b over a, we've halved it so it becomes b over 2a, we've then squared the whole lot, we've added it to the left hand side, but we've also added it to the right hand side so that the actual equation hasn't changed. The resulting mess can be tidied up a little bit by subtracting the c over a term from both sides of the equation. We can then expand out all the brackets, so the 2a all squared on the denominators become 2 squared, which is 4, and a squared is just a squared. We now have a pair of fractions on the right hand side which are subtracted. In order to subtract the fractions, what we're going to need to do is make them into a format where the denominators are the same so that they can be combined. We can achieve that by taking the c over a term and multiplying both top and bottom by 4a. Since the denominators are the same, it can just be combined as one fraction. And this leaves us with a perfect square on the left hand side, which means we can now factorise the perfect square. Now we're in a position to take the square root of both sides of the equation. However, because the square root only returns the positive root, we need to specify that we want both the positive and the negative roots. We can now subtract the b over 2a from both sides of the equation to get x on its own. And since both denominators have 2a on them, we can combine the fraction on the right so that we get the quadratic formula in the way that we are used to seeing it. Okay, well, so much for the theory. Let's have a go at putting this into practice. Let's take something like x squared plus 2x plus 1 equals 0. Okay, well, if we halve the numerical component of the x term, 2 divided by 2 is 1, and then 1 squared is 1. So we'll notice that this is already a perfect square, so there's nothing to complete. Since it's already a perfect square, we can just go right ahead and factor it. So this is x plus 1 squared is equal to 0. We can now take the square root of both sides. So x plus 1 equals the positive or negative square root of 0, both of which is positive or negative 0, which is 0. Which means x, there's only one value for x, and that is negative 1. If only they were all that simple. Okay, let's try something a little bit more hairy. Let's try something like 2x squared minus 11x plus 12 is equal to 0. Okay, we can start off by getting it into the x squared term by dividing everything through by 2. So that gets us our x squared on its own. So it's x squared minus 11 over 2 plus 12 over 2 is 6, and that's equal to 0. Okay then, so the next step is to halve the x term and then double it. Well, 11 over 2 or negative 11 over 2 when halved will become negative 11 over 4, and when squared that will become positive 11 squared over 4 squared, which is 121 over 16. So we've got to add to both sides of the equations 121 over 16. So we've got x squared minus 11 over 2x plus 121 over 16, and that's a nice perfect square there, so I'm actually going to move that 6 over as well, so that's equal to, we've got our 121 over 16 that we have to add to both sides, and then I'm subtracting the 6 from both sides, so that's minus 6. But instead of saying minus 6, I want to make it 16 times bigger and put that over 16 so it's compatible with the 121 over 16. Well, 6 times 16 is the same as 6 times 10 plus 6 times 6, which is 60 plus 36, or 96. So that's 96 over 16. Okay, so now the left hand side is a perfect square, so we can go ahead and factorize that. So that's x minus 11 over 4 squared. That's just basically half of the x term, and that's equal to, okay, well 121 minus 96, well if I was taking 100 away that would be 21, but I'm only taking 96 away, so I'm taking 4 less away from 121, so the 21 will be 21 plus 4, which is 25, so that's equal to 25 over 16, which is going to square root very beautifully. So if we square root both sides, I've got x minus 11 over 4 is equal to plus or minus the square root of 25 over 16. So that's plus or minus. Well, the square root of 25 is 5 and the square root of 16 is 4. Taking the 11 over 4 across the equals, we've got x is equal to 11 over 4 plus or minus 5 over 4. So either x is equal to 16 over 4, which is 11 plus 5, which is 16 over 4, and 16 over 4 is 4, or x is equal to, well, 11 minus 5 is 6, so that's 6 over 4, which simplifies to 3 over 2. So the solutions to 2x squared minus 11x plus 12 equals 0 is either x equals 4 or x equals 3 over 2. You can use this method of completing the square if you find learning methods easier than memorizing formulas. So if you're in the exam and you really can't remember your quadratic equation, just complete the square and use that method to solve your equation. Okay, I hope that was helpful. I'd like to wish you all the best with your revision and all the best with your exams. And in light of the events of yesterday, I would be grateful if you would join me in a minute's silence to commemorate the victims of the terrorist attack on Westminster.